So hello everyone, this is lecture 26 for the mathematical physics in which we were studying about the differential equations. In the last lecture we did up to here, we solved some linear differential equations of first order and find the ways to convert it into a linear form. Now in the today's lecture we will start with linear differential equation of second order. So these equations are of something this kind. This is the syntax. That is d square y by dx square plus px dy by dx plus qx y equal to rx. So this type of form is linear differential equation of second order. Okay. Now it can be written also like this: y double dash plus px y dash plus qx y equal to rx. Now there is this factor. If rx is not equal to 0, then we call the equation as non-homogeneous. But when rx equal to 0, we call the equation as homogeneous equation. Okay, so first we will see to find the solution of homogeneous equations when rx is 0. Okay, so let's put rx equal to 0 here. Now we will see how to find the solution of this equation. What is the fundamental theorem for this kind of equation? Let y1 and y2 are solutions of equation 1. Means we have solution of equation 1 as y1 and y2. There are two possible solutions. Then any linear combination, that is c1 y1 plus c2 y2, is also its solution. If these are the bases, we call them basis solution. Then the combination of these two in any combination that is linear combination of these two will also be its solution, where y1 y2 should be linearly independent. So we'll see how they are independent or not. So this combination is also the solution of the differential equation. This kind of combination c1 y1 plus c2 y2, and we can find the constant terms these c1 c2 like by the initial conditions, and they will be given in the question like y x not equal to k naught or y dash x not equal to k1. So just understand this like this, otherwise you will see the examples, then you will be more clear about these things. So what is basis of solution? As I told you, y1 y2. So it is a pair of solutions y1 y2 that are linearly independent. So they should be linearly independent, only then you can find these combinations which are also the solution. So how can we determine if they are linearly independent or not? So if this is equal to 0, then k1 and k2 both should be equal to 0. Only then you can call that y1 and y2 are linearly independent. Why? Because if any one of them is not 0, k1 and k2, then you can write other y1 and y2 in terms of the second one, which is not the property of linearly independence. Means both k1 and k2 should be 0, only then y1 and y2 will be linearly independent. Let's see if either k1 is not equal to 0 or k2 is not equal to 0, then y1 and y2 are linearly dependent. Why? Let's say k1 is not equal to 0. K1 is not equal to 0, then we can write this: y2 is equal to minus k1 y1 divided by k2. Sorry, you can write y1 is equal to minus k2 y2 divided by k1 here. And if k2 is not equal to 0, you can write y2 equal to minus k1 over k2 y1. Now they are a function of each other, and this is not a property of linear independence. That's why if k1 and k2 either of them is not 0, then they are not linearly dependent. The y1 and y2, the bases are not linearly dependent. We won't call them bases also. So that's how you can see this. Now we understand what are bases and how we find the. Now we'll see how to obtain these bases. If one solution is known, we know the one basis, that is y1 can be y2. Now we need to find the other one. So how can we find that? So that they both will be linearly independent and orthogonal. So let y1 is known solution. Y1 is known. Now we have to find the y2, second basis. So let's write y2 as u y1. So here u is function of x. Now you say that it is linearly independent, so y it is factor of something. So if y2 over y1 is some function of x, then we call it linearly independent. But if y2 over y1 came out to be some constant, then it is linearly dependent. Okay, so that's the difference. That's why we have taken this u as a function of x, so that y2 and y1 should be linearly independent. Now from this equation, differentiate this equation. y2 dash equal to use product rule, u dash y1 plus u y1 dash, and differentiating it again, then it will give you y2 double dash, u double dash y1 plus u dash y1 dash plus u dash y1 dash plus u y1 double dash. So this will give you 2 u dash y1 dash. So you will get this equation. Now now substitute this whole equation. Means if y2 is the solution, then you can write this. Means if y2 is solution, you can substitute this y2 here, y2 double dash plus px y2 dash plus qx y2. Because y2 is solution, we need to find y2 actually. So let's put y2 here. Okay, now we have this expression for y2 double dash, we have expression for y2 dash, and we have expression for y2. So let's substitute all of them. After that you can rearrange the equation and you will get something like this equation. So in it you will see, again rearranging the equation, you will just rearrange with u double dash as its factor. So u double dash y1 plus u dash 2y1 dash plus p y1 plus u, and it will be came out something like this. It's just rearranging. You can see how we are getting this. Okay, so now in this equation, you know y1 is already known, it is a solution. So y1 double dash plus px y1 plus qx y1 should be equal to 0. So here we are getting this, so this should be 0, and will remain with only this. So it can be written like this. Now let's say u dash equal to u, then u double dash will be u dash. So let's substitute. In place of u double dash, we will write u dash. In place of u dash, we will write capital U. Now this equation will be something like this. We will divide this whole equation by y1. So now we will came here. So this will be our expression, resulting expression. Now from here you can see this u dash is du by dx. So take this whole term to the right hand side, will be minus. Then u will be came into this denominator, and dx will came this side. So you will get this equation. Now integrating this, it will give you log u ln u and equal to this. Means it will be dy1 divided by dx, then dx multiplied this dx inside, you will get 2 1 upon y1 dy1 plus p dx. So after integration you will get 1 upon y1 dy1 will give you log y1, and this p dx is as it is, and some constant c. Now you can see this expression, so u should be exponential power to all of this, only then this expression is valid. Okay, so we have written u equal to e to the power this whole expression. So here it comes. Now let's say this ec1 c dash is some constant, and this 2 will came minus 2 will came in, it will be log y1 minus 2, and e to the power log x is x, so it will be 1 upon y1 square, and ec1 is some constant a, and this, so we'll get this expression. Now we have expression for capital U, and we know we have put u dash equal to u, so u will be integration of u. Obviously if differentiating u, you are getting this, then integrating this you will get u. So u we know it is this, so after substituting here we are getting expression for u, and we already written this, that y2 is u y1. So we have now the solution, means the other basis, that is y2, and that is nothing but u y1. So we will find u from here and put it here, and y1 is already known, so we'll get the second basis. So that's how you will solve the equation. Let's see one example. X square y double dash minus x y dash plus y equal to 0. So this is a homogeneous equation. Now first let's first solution is given, y1 is x. We have to find the second linearly independent solution. So we'll write y2 as u y1, and we need to find first capital U. So it will be a upon y1 square e to the power minus p dx. So first we will convert this equation in the form of this. So how you can convert this? Divide the whole equation by x square. You will get y double dash minus y dash over x plus y upon x square equal to 0. Now we have this px. After comparing, you can see we have px and we have qx. Okay, so to find this capital U, you need y1, that is x, already given, and you have p, and now you will get capital U. So capital U will be a upon x square. How it is x square? So it is y1 square and y1 is x, so a upon x square you will get here, multiply e to the power minus, this is p is minus 1 upon x dx, so it will be log x, and e to the log x will give you x, so x will cancel out and you will get a upon x as capital U. Now small u is nothing but u dx, so we have to integrate this. Integration of this will be a log x. So now you have small u is equal to a log x, and you know y2 is small u y1, so you will get this solution. And y1 is already known, so put it here x, so y2 will be ax log x. So that's how you can find the solution. To find these constant term, you need the initial conditions, which is not given in this question, but maybe in the some other. So we can see the solution of this question also. It's just same. So px is this minus 2x, and it is given that first solution is y1 equal to 1. We need to find second solution. It will be u y1. So we will find capital U. Capital U will be a upon y1 square, that is y1 is 1, a to the power minus this 2x, so px is this minus 2x, so a upon y1 square, a to the power minus plus, it will be x square by 2, so you will get e to the power x square. So capital U is this. Now small u is integration of this, so a e x square dx, so this will be your small u, and y2 will be u y1. You don't need to solve this because it is a little bit complex. You can write it in just this form only. Okay. Now let's see homogeneous equation with constant coefficients. Means here we were saying these as function of x. Now if there is some only constants a, b, c or anything, okay, so how can we find the solution of that equation? In a very easy way. So let's say this is the equation we have, y double dash plus ay dash plus by equal to 0. This is homogeneous equations with constant coefficients a and b. Now we know how to solve the linear equations, y dash plus ky equal to 0. This kind of solutions we get, means this kind of equations are linear equations, and solution of this equation is kind of this ae minus kx. So we already proved this kind of solution we have for the homogeneous equation where this right hand side is 0. Now if we differentiate it again, then we will get y double dash plus ky dash equal to 0. So this equation can also have this kind of solution. Solution will remain same. Means this is also the solution of this equation. That's why we can write the solution of this equation as y equal to e to the power lambda x. Okay, we assume that this is the solution of this equation. Now we will write a means just take the second order derivative of this first order derivative and y we have, so substitute it here. So you will get this lambda square e to the power lambda x plus a lambda e to the power lambda x b e to the power lambda x. So after taking e lambda x common, you will get this equation inside, and this will be equal to 0. Now this whole term should be equal to 0, and here we will try to find out the value of lambda. So we'll use the same formula for the quadratic equations we use. So lambda 1 will be minus b plus minus root b square minus 4ac divided by 2a. Here b is a and c is b and a is 1. So it is just minus a plus minus root a square minus 4b, and this is minus this. So you can find the lambda 1 lambda 2. So what the information these lambda 1 and lambda 2 gives us? So remember these formulas. If these roots are both real, then a square minus 4b should be greater than 0, only then roots will be real. Then solution can be written as this: y equal to c1 e to the power lambda 1x plus c2 e to the power lambda 2x. So this will be our solution. Here c1 c2 are constants, and lambda 1 lambda 2 are these values. Okay, now real double root means both roots are real but equal. So a square minus 4b will be 0, and you will have roots as minus a by 2. So solution will be y equal to c1 plus c2x e to the power lambda x. Here c1 c2 are constants and you know lambda. This is minus a by 2. Now if you are getting complex roots, lambda 1 lambda 2 are complex, something like alpha plus minus I beta, then a square minus 4b should be less than 0, only then you can get complex roots. So solution can be written as y equal to exponential alpha x c1 cos beta x plus c2 sin beta x. Here alpha came from here and beta came from here, and c1 c2 are constants. So when we see the questions, we will see that you can find these c1 c2 in any of the case by just when the initial conditions are given. Okay, so let's see some questions, then it will be more clear to you. We will see question of all the three cases. First, this is the equation: a is 1, b is minus 2, and conditions are given: y 0 4, y dash 0 minus 5. So we can directly write from here lambda square plus lambda minus 2 equal to 0. Find the value of lambda, it will be minus 2 1. So both are real and not equal. So solution will be c1 ex plus c2 e to the power minus 2x, and it is lambda 1x lambda 2x, so 1 and minus 2, that's how we taken this. So you have y, you will find the y dash from here. Now use these initial conditions. y0 is 4, so 0 will give you c1 plus c2 equal to 4, and this equation is at 0 it is minus 5, so c1 minus 2 c2 will be minus 5. So this equation can be solved and c1 c2 can be found. They will be 1 and 3, so just substitute them in this equation, you will get the solution. It will be y equal to ex plus 3 e to the power minus 2x. So this will be your solution. Now let's see one more equation. This is the equation and initial conditions are given, so just write it: lambda square minus 4 lambda plus 4 equal to 0. You will get lambda will be 2 and 2, so both are same and double roots, so y will be c1 plus c2x e to the power 2x. From the initial conditions, y at 0 is 3, so it will be c1 equal to 3, and find the c dash or y dash from here and use the second condition. You will find c2 also, it will be minus 5. Now just substitute them inside this equation, you have the solution. Let's see the third. So this is given, initial condition is given, so you can write lambda square plus 0.2 lambda plus 4.01 equal to 0, and lambda will be minus b plus minus root b square minus 4ac divided by 2a. So this will be your lambda, means this is minus 0.1 plus minus 2i. So it can be compared with alpha plus minus beta I. So alpha will be minus 0.1, beta will be 2. Now solution is y equal to exponential alpha x. So alpha is minus 0.1, so it will be this: c1 cos beta x plus c2 sin beta x. So beta is 2, that's why it is 2 here. Now use the condition. So y at 0 is 0, so this is 0, so this will give us 0. This is c1, so c1 will be 0 from here, and y dash will be, just differentiate this equation by using product rule. Dot, first differentiate this, then this, so it will be this. Now use the second condition, y dash 0 will be 2, so substitute the values, and we already know c1 is 0, so from here to c2 equal to 2, so c2 will be 1. Now you can just substitute this, c2 is 1 here and it is 0, so solution will be y equal to e exponential minus 0.1x sin 2x. So this will be our solution. Okay. So that's all for the today. Thank you everyone.